bingo. Look, all the cameras and everything are set up properly today. That's miraculous. And we got tunes. This is great. What a great start. And I've had a haircut. Yay. So it's not so hot in here anymore. Supleak Hackers. Yes. Robsky Rob. JC1980. Ice Dragon D. Rob Smith Dev. Metal Gear Streamer. Yeah. Literally. Braxton. Commander Keen. Mads. Much love, my dear. I hope you are well. Doxter with the sub, thank you very much, mate. 26 months. Oh, that is amazing. Hair look Brillhoff, thanks. Well, give them my hairdresser. Is, you know, she's in high demand and she lives in the same house. So, you know, yeah, it's a constant fight to actually get the haircut. Derek, welcome in. Who's that? Lexi as well, welcome in. Manimo, obviously. Ice Dragon D. Mad Pew. Curl, Commander Keen, of course. Booney, how you doing, mate? Oh, don't. Well, hang on. Let's just have a look then, shall we? When can you get a weekend off then, mate? You free next weekend? Come to Salisbury. Not this weekend. I'm up north this weekend. Unless you want to come up north with us, you have to get here by Saturday morning. Good luck. No, then I'm away. Oh yeah, then it's 1, 2, 3 weeks. Oh my goodness, August is full. Yeah, I'm at Zap Live, and then I'm at Shambhala, and then I'm in Poland for Xenium, and then we're into September. You'll give it a go. Up north, yes, up north to see the fam. Yeah, Sarah's, my wife's Sarah's family's from kind of Dewsbury way, kind of outskirts of Leeds. So, yeah. Support worker, innit? Yeah, I know. Well, try it anyway, if you can. It'd be lovely to see you, as it always is. So, yeah, I'll take you down Sips, yeah? Which would be expensive on my wallet. Sips is a bar in town. Anyway, we're supposed to be doing a stream, not organising my social calendar with my daughter. Anyway, Kato, mate, ain't seen you for ages. Hope you're well, mate. Who else did I see there? Robsky Rob. I've said hello to everyone. Sips, yes. Yes, mate. We'll go down there. It's all right. We're doing a bit of patter anyway. So it's all good. Oh, Hooverphonic, mate. How you doing? Welcome in. What did we do last week? So, last week, oh yeah, we demoed the music disc tech stuff. So this week, let me just minimise my Discord so that you can't see that. This week, we're going to build an Amiga executable compressor. Well, sort of. Right, we're going to use ZXO and then build a wrapper around it and stuff. I'll explain later, but basically, missed last week. Oh, you missed the fantastic music disc technology showcase. Riker77, welcome in. It's pretty bloody good, actually. Also, we did show you the nearly finished version of the hyper-based remix. That's finished now, and there's also another techno tune that you can listen to that I wrote, which is a lot darker. So we'll roll those out. Now, I would normally at this point say, hang on, wait a minute. Bear with me. Ban at space aspire. There we go. Bye bye. Oh, right. I see. Now I got you thinking about executable packers. Well, that's what you'll need to build one then, won't you? So I would normally. There's no point asking for a number, right? I haven't written any discs yet, right? Just get my Barnet cut, so I ran out of time. But this does lead us into quite possibly one of the most dangerous things we've ever done on this stream. So, I don't think you'll see it here, will you? We got an about in here. You can't see it. Hang on. Let me disappear a moment. Where am I? Main cam. I'll disappear. What's that? Mod. Dying rainforest. Look at that. So we all know about this little bad boy, don't we? DiskFlashback. We have covered it on the stream before. But Rob Smith Dev is on the verge of releasing a new version. And let me just bring up this text file here so you can see all the new features. Mount physical Amiga hard drive memory cards as drive letters, which is mental. That's great. Sped up Grease Weasel support, which is great. Added special message for people just trying to run DiskFlashback exe and wondering why it doesn't do anything. Well, I mean, where is it? DiskFlashback, yeah, okay. Open file location. And you can't see what's, you can't see it. Hang on. Here we go. Oh, interesting. Okay, well that's not done anything there. Oh. Well, Rob, that doesn't seem to work. We're beta testing live on stream. Exactly. Yeah. That is actually the thing I was most interested in because the Grease Weasel support. You broke it again. Probably, mate. So the Grease Weasel support. So if you don't know, oh yeah, you can't see it at the moment. Let me just do this a sec. So this is a floppy drive. That's a Grease Weasel. That little USB doohickey, USB, blah blah, connecty, good. It takes full control of the drive and lets you read and write all manner of goodness onto floppy disks. But the DiskFlashback is obviously, if you don't know what that is, it's a tool that you install into Windows and then you can read and write Amiga floppy disks, either images, physical disks via Grease Weasel, via floppy bridge. It's amazing. And this is the new version. So what we're going to do is we're going to take it for a test drive, right? Because what's the worst that could happen? What is the worst that could happen? So, we need a demo first. I'll tell you what we will do, actually. I'll tell you what we will do, because we haven't seen it for a little while, and I forgot that, I just forget, you know. I just forget. Let's go to Poe, Circumvent, download, yeah. Save as, desktop DM. So let's go into that folder a sec. Desktop DM. Let's just clear it out. Don't need any of that anymore. There we go. Right. Save that in there. Right. So this is the beauty of this thing, right? So I've put a blank disk in here. You can see that. Put it back down over there. And then if we open that up, take this. Oh dear. Yeah. Come on. Take that ADF and dump that in there. Then you can right click this ADF and say copy to disk. Weird. No. What's going on? No. Hang on, something's gone wrong here, hasn't it? Floppy drive enabled. Copy file to disk. Alright, we'll do it that way. You can do the right click. I don't know why that's gone wrong, mate. It's all broke for me. Yeah, I know. I mean, this is why. Anyway, the important thing is, will this blue screen my machine? Oh, for goodness sake. Okay, right. Hang on. Eject that. There we go. There we go. Right, now. Rob, you're fired. Yeah. Oh. That is quicker. Okay, there was a little pause between some of those tracks, but it does feel... It feels a lot quicker than it was. Let's ship Rob's machine. Yeah, you can hear that, can't you, Rob? This is a slight pause every now and then. I mean, I don't know what you're deving this against, but Hang on. I'll show you what we got in here. It's quite old now, really, by comparison, but it's still I wouldn't say it's formidable. There you go, an i7 8700K, 3.7 gigahertz, 16 gig RAM. Probably should put some more in there at some point. No, it's verifying. Could also be this this cable. I don't know. Do you get firmware updates for the Grease Weasel? Should I be doing? Is that a thing? No. Okay, so maybe I should do that. I haven't done it since I bought it, to be honest. Right. So actually, now that's done on that disc. If we go to File Explorer and then go this PC, we should see Drive A, exe to ADF, Circumvent. There we go. And there's even a startup sequence here. Look. There you go. There's updates you can do with the exe. Okay. Hello, Cloak Taylor, mate. How you doing? Right. So that means we can do our first demo then. I am back there. That's good. Hang on. I'm pressing all the wrong buttons. Sorry. Right. Bingo. Right. Circumvent by TTE. That is a lot quicker though, Rob. I'm impressed with that. Very good. And you notice that the decompression color we used is that tiny little square there. Hello, Flow From. So that it doesn't. So I decided on this because then it wouldn't kill the stream when we're watching demos, rather than doing full screen or even like the other thing with the other color. Do you know what's going on there? You can see something's happening. Oh, here we go. I'm gonna shut up now. Okay, we're ready for it to crash because I think this is the yeah. There we go. Yeah, it's the crashy version. It says final. It's not final. Knackered. Okay, there we go. Well, now you know what's a demo without a software failure, right? You know, it's part and parcel of it, right? Anyway, there we go. Circumvent by the Twitch Elite. Didier, welcome in. Dodge as well. Nice to see you there, mate. Yeah, that was a demo. Got to change file name to actually not final underscore now, and then underscore 07 underscore FFS underscore really underscore final. And then I think you might be just about there then. Hang on. Lovely. Oh yeah, today's tipple of choice is basically a massive pack of San Miguel, which are cold, thank God. Sorry. And they are slipping down very nicely. So yeah, let's go back to desktop. And let's pick another demo and then write it straight to disk using DiskFlashback. Anyone got any suggestions, any preferences they'd like to see? Anything they'd like us to watch? Actually, I'll tell you what we could do. Let's test something. I know what we can do. Aldi knockoff westerns. Nothing wrong with Aldi knockoffs, man. Just the best. What's that? 30 years of assembly. Oh, right. Now, this used to fail because the DMS has got like a weird BBS thing in it. Where did I do that? Desktop.dm. Excellent. Right, now let's see if this works this time. Copy to disk. Oh yeah, that's really not working today, is it? Okay, I'll do it the other way. Floppy drive. Copy file to disk. Here we go. Right. Yes. That's so much quicker now. Yeah, mate, I love Aldi. It's brilliant. It's my favourite shop. So yeah. To be fair, it's made by Westerns, just a sus name. To be fair, a lot of the stuff that goes to Aldi is made by the same people. It's just one conveyor belt. It just separates out a percentage, doesn't it? And then gets put in a different package. Hey, it's quite a lot of swearing on this. Maybe we'll skip that. And it's a lot quicker. This is let's give Rob Smith a round of applause. Very good. Very, very good. Now, if this works, then we're on to a real winner, because DMS files, old school DMS files, are a pain in the arse. So, if this works, and also we get to watch 242 by Fairlight, which is an amazing demo. So, look at it go. You're gonna make me press the button, aren't you? I'm going to press the button. You can have it. Here you go.
US Gold present from Sega.
Right, that's enough of that silliness. Oh, there I am. Oh, there we go. Lovely. Right. Let's just see me. I suppose the other option, right? Okay, I've put that away somewhere. I bought a Go drive when I was at Kickstart, which would allow me to add GoTech, which is switchable between the floppy drive. But you know, I have to open up the Amiga for that. Maybe we'll do a hardware stream next week, eh? Installing a Go drive, maybe, or maybe we'll do it later. Right. Does it work? There you go. That's another win, Rob. The demo that's always so annoying. Well done. See, now that's what you call a proper developer. You tell him something's wrong, and he goes and fixes it because he cares. Rob Smith cares. Anyway, this is 242 by Fairlight and Virtual Dreams. And it's a bit of a cracker. So, that's a quick track loader. Yeah, it hasn't loaded yet though. It's quick though. There we go. 242 by Fairlight and Virtual Dreams. If you read this text now, it will tell you that you can buy his video compression algorithm if you want for a lot of money. And now we have open source video compression algorithms for free, which are better than that. So, there we go. Classic. I wonder if anyone did. I doubt it. He might have been able to get a job with it though. Like, look at what I did. So, yeah. Right. As requested by Pyro. Chiller Bits by Offense, and who was the other group? The other one. What they called? Thank you. Yes, you wrote it there earlier, and I've completely forgotten what. By Offense. It started. think that's loot now? Honestly, if that's going to spend all this time scrolling the word revision on screen, oh, it is as well, isn't it? Pyro, you ain't wrong. We had loads of problems getting that running. Ghost magic. The ending is disappointing. Right, well, we're done with that then. Anyway. That does get a serious Seeks to Fork guys demand a long attention span. They peaked too early, yeah. Hey Banjo Golly, mate, how you doing? I'm kidding. I mean, I'm not kidding. I really want you to do a cover of Eon. But anyway, you know, welcome to the stream, mate. I hope you're well. I guess, am I going to bump into you in October at Terrible Fire's place? What? Because if so, that would be great. Yes. Clappity clap. Let's get some background music. Possibly. Perfect. Excellent. TF 4060 release party. I don't know. I figured he'd finished it already. People are building it now, aren't they? Zeron, mate, how you doing? Well, I'm definitely going. I've got flights booked to Glasgow for the weekend, or Glasgow. So, depending on whether I'm down south or up north. So, you're pretty good. Well, let's give Zeron a round of applause. He's completed another cycle around the planet. And has now got an Amiga 1200 with the TF 1230 in it. So, yeah, he now owns an Amiga again. So, expect great things, because he now owns a piece of hardware, which means he wants to make demos for it. So, yeah, it's awesome. Excellent. Excellent. That's all I like to hear. I sincerely hoped you did run the textual healing release on your new Amiga 1200 and that it didn't crash. So, I hope so. I hope it didn't crash. Oh, that is something actually. So there are a couple of things that we could be doing, but yeah. Not yet, but you will. Excellent. To be fair, I didn't even run it on my 1200. I should have done. Someone did log a bug with me for Seekanoid. Apparently, if you complete the main game and get over 10 million, it crashes when it tries to go to the scoreboard. So, we might have to test that out maybe later. So, we'll see how we get on. Let's because it's time's getting on. So let's get to the desktop. So what are we doing today? We're trying to build an executable compressor. And I'm going to do this the hackiest way possible, right? What are your views on consensus on distributed systems? If it works for you. I don't know. What I can tell you is that's an Amiga 500. And it was distributed by Commodore, and I own one. So yeah, this is effectively a distributed system, right? Where were we then? Desktop. Yes, Amiga cluster demo. There is that C64 demo called Quad Core, where they ran the demo on 4 separate Commodore 64s at the same time. Multi-processor. No, it was called Quad Core, wasn't it? Hang on. We have to look it up now. I just need to stop opening that. Connected by SneakerNet. I can't type today, can I? Here we go. I think it was called Quad Core, wasn't it? Quad Core. There it is. Yeah. So each corner of the screen is basically a Commodore 64. So the demo runs across 4 screens. So, yeah. Not a quad trip. No, there we go. Will there be overlay hunks? Oh, what, in the compressor? No. 12-channel SID tune as well. Yeah. Yeah, crazy stuff. Anyway, if you want to watch that, go and... I mean, you know, no one can run the demo, can they? So... Eludiella, thanks for the follow. Right, so what we're doing, we're going to build an executable compressor, but we're going to do a super hacky job of this, right? So, how do I explain this? Ghost Magic is now following, thank you very much. So, for Nightmare, Metal Gear, and Seekonoid, to get the game on... No one wants to think about Hunk overlay, no. For that, I built a thing that would basically take apart an Amiga executable, and then just summarize it into two binary chunks, right? You'd have the section for chip memory and the section for slow/fast memory. So what I'm going to do is basically take that and then wrap that into something and see if we can ZXO compress it and turn it into an executable. So I'm not a hunk, so not many people want to overlay me. Xeron. Fucking hell, mate. Look up NCC neural network compressor, but if the decompressor can't work on a 68,000 at 7 megahertz in a timely fashion, then there's no point. So the thing we're going to do today is we're going to basically, I'm just going to do like a little test. I want to see if we can take those 2 hunks that I get out of that hunk ripper, wrap that in an EXE, well, ZXO compress those 2 chunks, and then wrap that in an executable to uncompress them. So, how do we do that? So first of all, I think what we need to do is come up with a name for this thing. Actually, no, first things first, let's fire up good old C#, because this is where I'm going to do this stuff. You love like Semtex, you're proud of your dad bod, so am I. Well, I'm not actually. Can't see it. You can't see it, but it's all bought and paid for, isn't it? So, right. So we'll call this. There's a compressor we're going to use is ZXO, but we'll call this Zexio. Zexio? We call it that? Yeah. Yeah. Hoffman Cruncher, best matches, Pro Tracker modules while loading. Actually, Hoffman Cruncher decrunches your samples while loading. So, okay, let's just console.app.net framework. Yeah, I know it's out of support and the rest of it. Zexi0. That's what we're going to call it. Okay, C/code. Yeah, Zexi0. Do it as 4.8. There we go. That'll do. That's all I want to start with. Okay, so the first thing I want to do is I've got another project here. Is that going to play some tune? Come on. I'm going to add a reference to... Oh, that. Wrote a tool that can remove hunks, merge executables, convert between Kickstart 2 and 1.3 relocks, etc. Use it to create my hacks that patch programs before running the original. Oh, right. For example, the X copy I created, you used it. Okay. Too bad I've misplaced the source code. Yeah, I tell you what else I've misplaced the source code for. Is this thing, which is my Amiga sample creator. Yeah, I wrote it ages ago, lost the source code, but I can still use it, so it's fine. But I should rewrite it at some point. I was a terrible coder then. I haven't improved much. You can run C# on Amiga? No, of course not. Going to compile it in some other binary form. So basically, I do loads of stuff in C#. It's just the language I'm most comfortable with. So that's why I use it a lot, because I can get stuff done dead quick. And a lot of the stuff I've written, so my ProTracker tools, for example, is all written in C#, so I can plug that in whenever I want and basically completely and utterly decimate and rip apart ProTracker modules and reconstruct them any way I want, optimize them, all sorts of shenanigans. So it's just like with everything we do here, a lot of stuff is done off system because it's a sensible thing to do. Try .peak on it, matey. Might get most of your work back. Oh no, this. The thing that. I'm. To be fair, I wrote it in about 20 minutes. I could probably write it again in 15. So there's no real need to. It does work. And Proton is raiding. Hello, Proton. How are you doing? Not this issue, but the next issue, your Cyberman 6 demo was reviewed. So keep an eye out for that. Cross dev, that's what we do. Yeah. That's absolutely right. And we're gonna generate some tools on PC side that will spit out a binary that we can use on an Amiga. Well, sort of. This is going to be so hacky you won't believe. Right, so let me add a reference first. Add a reference to projects. Let's browse Hunk Ripper. There it is. And actually, what I might need to do is open it up because I don't know I can't remember. This is some really early code that I wrote. Okay, so. Hunk Ripper. Oh, good. How's the demo coming along? We haven't got a demo going. We do have a music disc in the works. Oh, do you know what? Before we get totally into this, who wants to hear the Hyperbased remix that's finished? Yes. Okay. Right. I can just go straight to here, can't I? Because this is set up correctly. Oh, I can do this as well, can't I? Bam. Oh, it's so handy, that. Such great. Okay, based. Let's hope I've got this loud enough. Hyperbased by Tippermantronics. This is the Hoffman deconstruction mix. There you go. It's oh no, he can't. What he can't do is press buttons. And this song is 16-bit. The samples are 8-bit. What? Why is that not? Oh, that's why. Because that sample is silent. They're 8-bit, but it's obviously controlled by Amiga, so. What program is this? This is Pro Tracker. That's what you need. So you can play a proper... And that's it. That's all the samples in there. So yeah, that's Pro Tracker. If you don't know what Pro Tracker is, it's a music program, an incredibly popular music program. Now for the Mark Saul bit. Yeah, exactly. Yeah. So yeah. Right. Let's get on with the business then, shall we? Right. So. There we go. Bit more. There we go. Background music. Right. So. No, I'm using, so that's Pro Tracker 2 clone for Windows, Mac and Linux. You can basically, it's a complete virtually a one-to-one port of the Amiga version of Pro Tracker made in 1990 something, and you can run it on Windows. And it's really handy for me because I can play tunes and stuff, and you can see them as they're being played. So, right, so. On to business then. So, no, that is... What is that? Oh, that's the mod mix from last week. What is that? Keyboard? That's Seekonoid. Okay, no, we need to... we'll see. We might get on to trying to fix that bug later. We'll see. Okay, right, so... Here we go, right. Hunk Ripper. So, what does Hunk Ripper do? Okay, so we've got that. So, I want to... That's what I want to do. Deserialize exe and then merge hunks. That's the two things I want to do.
My eyes, the goggles do nothing.
Yeah, it would be helpful if you could see what I was doing, wouldn't you? Yeah, there we go. Right, let's move that over there a bit. Right, beautiful. Right, so this is Hunk Ripper. This is something I wrote ages ago that takes an Amiga executable and breaks it down and deserializes it. It doesn't reserialize it, so I should have sorted that out, but yeah. So just merging a code data VBS hunks all together, relock it all once and jump in. That's basically what we're going to do today. So that's basically how Seekonoid works from floppy disk. The game is basically, the executable is in like a bunch of hunks that can be, so you can keep track of how big certain things are, and then this processes it into basically two blocks, right, which is a block for chip memory and a block for fast memory. And what it does is it puts the BSS hunks, or the empty hunks of memory allocation, at the end, and then hides the relocation table in there, and it's a tiny piece of code to relocate it. So yeah. So I mean, we're just doing this as an experiment to see if it would work, right? And I needed to work out how Hunk Ripper worked again, and we might have to go back to that and pop back in. So first thing we want to do is So we need an exe. Then we need a couple hunks. Then we need to pack them and spit them out, right? Beautiful. Right, so we need an exe. So what I should do is go var file name equals. Right, we'll get that from arguments later, but I need Minimo. On my work computer I do have Copilot, and more often than not it generates giant chunks of shit that I don't want, but other times it's quite handy. But yeah, most of the time it is shit. So I need an executable. So I guess circa it's got a 10 million bug. Yeah. Apparently, I haven't tested it yet. So maybe circumvent them. Maybe circumvent. That'll probably be a good start because there's a chunk of hunks in that. So, and I think I've probably got. Actually, I've got really old build on here, haven't I? Actually, let's do as an experiment. Let's do the TTE textual healing pack from last week, right? So UAE DH0, and we've got doc view. Okay. So there we go. We've got docview.exe. So let's try that out and let's see what we get, because I don't think that's that huge. Doc view, right? So we need an exe. We've got an exe. So no. There we go. Where was it? Hunk Ripper. There we go. And that's what we want. Hide that. Oh, look at that. Oh my god, that's quite easy, isn't it? Right, so let's just check that out and let's have a look and see what we get. Okay, bam, bam, bam. Right, so hunks. Let's have a look at the hunks we've got. Right. Okay, so actually we've got 6 hunks and 6 hunk sizes. So we've got code, and we've got data, BSS. Okay, cool. And that should say whether it's chipram false or chipram true. Okay, cool. Right. Okay, so there's a few hunks in this. And then we should have 2 binary blocks left over, right? Oh, actually, it's got data size there and a hunk size. Oh, okay, cool. That's handy. I was forward thinking. And it's got a BSS size, so we know how big everything needs to be. Okay, this is quite good. How are we doing for time? Oh my goodness! We have to do a BRB already. Jesus. All right. Okay. I mean, I have run out of beer, so we need to pack these. Right. So. Oh, I mean, there's no point asking you lot, is there? Right? You all want the imploder, don't you? Hands up if you want the imploder BRB. All right. I'll give you the imploder one, right? I'll be back in a bit. Much love. Hello Raiders, welcome in T2SDE. What are we up to? Welcome in. My name's Hoffman. If you've not been here before, we do programming mostly on things like this. No, that's me. There we go. That's the Amiga 500. That usually stays out most days. So today we're building an Amiga executable compressor. Kind of a bit of a weird hacky job. So I love like Semtex. Benimo posted the Imploder 3 tune the other day. It's nowhere near as good. Neversoft, you absolute legend. Adventure Josh, Electronic Botulism, Dawn Perignon, Ben, and Joggy. Give Neversoft a hug. He's gifted you a sub. Thank you very much. Can you bear with me a minute? I'm doing important business here. Look at that. That is actually... Cheers. Mortal already? Yeah. How you doing, geezer, mate? I ain't seen you for ages. I hope that means that you're busy working away on your next classic. I do. Ain't seen you for ages, mate. I hope you're alright. I'm building an executable compressor today. Been in Lanzarote. Oh, maybe you come home and it's bloody hot still, right? Like you're still on holiday. So yeah, we're building a very, loving it. Hang on, let me just put a disc in. Oh no, I can't. If I put one of those discs in, hang on. There we go. Put that in. There we go. All the context menu issues is because you missed a single quote mark. Oh, well, Rob, you know, this is why you... What I can tell you is the easiest way to find bugs is to give it to someone else to run on stream, because then it's live and it's someone else's hardware. So, you know, that's how those things work. Right, so what we're going to do, the idea of this compressor is we're going to basically squeeze the executable into two hunks, one for chip memory and one for slow/fast memory. That part I've already got done because I've used it for Circumvent and Metal Gear. Right, so as we can see here, I've got two new hunks here. I've got a BSS position. I've got a BSS size. Okay. Sorry. If that's the chip RAM section. That's the physical data. It's the data size, the hunk size. And the hunk type. Okay, so that's just flop. And there's relock stuff there, but that's all done into the... That looks weird. Oh, hang on. Oh, that's why. That's why. Right. So we need a chip and a fast section. That's why. Okay. Yeah. That's. I forgot about that bit. Okay. Right. Let's do that again. Right, that serialize would do the important stuff for us, right? Let's just run that again. I've been in Android Studio all day, so all the F keys I use for stepping through are completely different. Okay, that looks better. Right, so just as a test then, let's make a new folder. C:/code/ and we called it ZXC0, and then we'll just do a new folder in here called oh, for fuck's sake. Okay, C:/code/ actually let's put in ZXC0, and then in here we'll put a new folder called ASM, right? So that we put it in there. Okay, and then we're just going to do some hard-coded parts because I'm a dirty. Okay, let's bin out some tests, right? So, for fuck's sake, there it is. then back again. There we go. Okay, so you've got data chip, data fast. Right, so what we're going to do is var test path equals... Oh, such a banger of a tune, this. The Crunch by Juice. Such a good tune. Let's stop that. So code ZX. Okay, right. ASM. Yeah, there we go. Right, so that's going to be our test output path. We're just going to do some testing first, right, to see if what I'm thinking actually works, right? So, file dot. Oh, I hate. Why does it always do that? Thank you. Dot write all bytes. Yeah. Okay. Path dot combine. Test path. Chip dot bin. Yep. Didier, thank you so much, mate. Marco, Data, Ghost Magic, GW1SXP, and DJ Rick Carbonal. Oh, that's a nice name, isn't it? Give your man Didier a hug because he's gifted you a sub. Top bloke. Data chip. Okay, there we go. Oh, I see what I've done there. Okay. Okay, right. Yeah, I see. Right. Okay, and then we just do the same again. Data fast. Yeah, there we go. And we'll call that fast.bin, right? Right, so all I want to do for this first run is show what we've ended up with. That's what they should call slow RAM, shouldn't they? Because it's like being fisted. Right, so fist.bin. Okay, so there we go. So this is just the raw. This is just the raw data, and what I can show you in here, if we show this in HXD, right? Chip.bin. So what you have is that is the location within this binary file of the BSS or the memory allocation, and also what we do inside the BSS is we hide the relocation table, and that is the size of the BSS section, right? So what we need to do is we need to, as you can see, the chip mem section that we've got for textual healing is really small. It's just some copper lists, I think, and maybe a mouse pointer or two. Yeah, there's fucking nothing really, is there? Fast mem, on the other hand, as you can see here, there's the BSS location. That's the size of the BSS because it's quite large. And you can see that looks like an instruction. That looks like 68,000. Yep, copper list. Yeah, you can see it, can't you? And that looks like a 68,000 instruction, doesn't it? So, someone write that quote down. Clip it. Well, someone's going to, aren't they? Right, so, what we want to do is we want to work out. Look at that. That is disgraceful. And look at that empty space. You should have put that in the BSS section. You should be ashamed of yourself. Look at that. Right, and the rest of that's ZXO compressed data, so it's not going to compress at all, really. But what I want to do in the first instance, there's our relocation table. Xeron as well. Come on, mate. Jack Skater. Bender Unit. Depeche of Spreadpoint. Love Like Semtext and Coco. Give Xeron a hug because he's just gifted you a sub. I'll say cheers to that. Alright. I swear I saw something that said source 00. You did. source 00. There it is. So what source 00 is I can explain this one. We can just do a quick detour on this, right? So in Pablo Draw, right? Now you may have seen this over the last bunch of streams. If we open up a file that we are very familiar with, I think if we go to D/Nova 2024 ASCII, just grab one of these. No, not one of those. Grab this ANSI. So remember this from Textual Healing. Wrote a whole thing to show these. If we just take a little side hustle across over to D/Nova 2024 ASCII, and it's number 5, was it? Yeah. So that's the ANSI file in hexadecimal. So you see all these control codes, they control the color, yada yada, and then you see characters. There you go. Yeah. Right down the bottom, what Pablo Draw does is it writes a source at the end here that will give you like a date, it will give you a name, it will give you the name of the font that you're supposed to use and all this kind of stuff. But my ASCII ANSI writer was basically printing out a source and then some garbage afterwards. So part of the code basically looks, when it uncompresses the text file for displaying the in the pack, after it's compressed, it looks for that string at the end of the file and then just lops it off basically. So that's what the source is. Anyway, that's by the by. That's a complete sidetrack. Right. So what we need to do now then is just set up something in VS Code. Open folder C/code/ZXE. Commander Keen. That's too nice of you. You lot are amazing, you know that. Apollo Dev, Namco's, Fluffy Martin, Dapper SW, and Space Cadet Marky. Oh, it's a great name as well. Welcome to the stream. Commander Keen's gifted you a sub. Give him a hug. Clap, clap, clap. Thank you very much. Right, into the ASM folder, select that. Don't save. I don't know what I was doing there. Right, so I'm going to cheat here. Amiga assembly. Dockster, there's two kind. Magic Ninny, Drummer Wayne, Nefariu, and Cattle. Give Dockster a hug. He's also gifted you a sub. Just spam there. Spammer alert. The Dockster's not a spammer. I made music for his Amiga game. We'll call this main, right? Oh no, path doesn't exist. No, that's fine. So just creating a new workspace here. Program name, we'll call it main. Doesn't matter. I'm going to replace. Yes, I do want to use it. That's fine. I'm going to replace all this. It just puts all the includes and stuff in here. And let me just reveal in there. Okay, and then there, new folder, build. There we go. Right, beautiful. I'm going to get rid of that. Move it to the recycle bin. I'm going to get a new file called main.asm. Right, there we go. And we're going to call this ZXC0 Amiga ZXO EXE Unpacker. So if we're going to make an unpacker on an Amiga side, we need some source code to do it, right? It's too warm to code. Fucking lightweight. How you doing, Steve? Stephen, sorry. I don't know whether you like being called Steve or Stephen. I imagine you don't care. Most people call you Terrible Fire though, right? Oh. I don't have a lighter. Your wife laughs if someone calls you Steve. I tell you what, Terrible Fire. I'll let you into a little secret. You know Andrew from Immortal Joysticks? Call him Andy. He fucking loves it. He really loves it. Anyway. Let's just do a test, right? Move.wd0 into 180. Right, okay, yep. Sub q.w1 from d0 and then BRA main, right? So all that's going to do is basically just that's too. Oh, we leave it there actually. It's a bit easier to read, isn't it? No, fuck it, yeah. Right, let's get that up and running, which means I'll need a task. Let's get rid of these Amiga assembly specific tasks. I don't want those. Let's go and steal the ones I used from where was it? Doc view 2. Yeah, there we go. And I want from there tasks. Okay. We're just going to relabel the copy. Thank you. Yeah, there we go. We're just going to relabel these as doc view. We'll change that to main. Yeah, main. Yeah, lovely. Yeah. Okay, so build main. It built some code. There we go. This is a fantastic start. And now on launch, I'm going to get rid of all this crap that it puts in here as well. I don't want any of that. And then I'm just going to steal a launch from the previous project. From launch. Copy that. Copy, yep. Paste that into there. And then what? Gigabytes? Mate, need to do that. Curl. Underdose, LFC, going digital. I ain't seen you for a while going digital. I hope you're alright, mate. Mike Zero Team and Odd Bod. Give Gigabytes a hug. He's gifted you a sub. I'm gonna have to find a more snappier way of saying that, aren't I? It's just not. It's not very cool, is it? But yeah, you lovely person, Graham. I've got to say, Graham, it was lovely to see you and your wife at the after party at Kickstart this year. It was fab. Yeah, I hope you both had a fab time. It looked like you both had a fab time, if I'm honest. Like, no kids. You were drinking and having fun. So yeah, it was lovely to see you both having fun. So, right, now let's see. Theoretically, so we're just doing like just a test build at the moment, right? Can we get some Amiga code running? We want that a bit over here, don't we? Yay! Right. It was great. It was great, actually, this year. At least the sound system was better than last year. So, right. So, what I need then. So, my plan is to have 3 sections for this, right? Ship hit. I think. So, I need a chip section. So, okay. So, we need a section here called Unpacker, right? And it's code. And I don't care where it goes, right? Right. And I have a section called data underscore chip, and that's data in chip RAM, right? And we're going to data underscore chip, right? We can make this a lot more, dynamic and what have you. But for the moment, we're gonna. You actually caught me off guard with that one. Right, chip.bin. Right. And then section data underscore fast. Data, right? And data underscore fast, right? Ink bin fast.bin, right? And that'll do square root of faff all, apart from the fact that you can now see we've got an unpacker that's 10 bytes, which doesn't actually unpack anything. We've got a data set, we've got a chip section and a fast section. So what we need to do is work out how much extra space, right? And now I'm going to do an experiment here, right? So let's just say, for example, DCB.B $1000, right? Right. Right, now it says that section is now 68,000 bytes. Right, I just want to have a look at that in HXD because I have a feeling that Viasm is a good boy and will do us an absolute solid in this scenario. If it doesn't, then we're going to have to work out how to do it properly or hack it. So code / Zexy. I just realised I called it Zexy. ASM UAE DH0 main. Okay. Oh, brilliant. It's done exactly what I thought it would do. Yes. Fucking yes. Okay, this is going to make this a lot easier. So, now you'll see here. Let's just separate these out a bit, right? Because it did this to me once. Chip mem section, right? And then we'll just separate this one out as well, just so you can see, right? Fast mem section, right? The code doesn't need to be PC relative at all. I know it will, but yeah, I don't need that. I don't need that today. I'm leaning into what it does. So now, this is our chip memory section here, right? So I've got a label here, it's called data chip. And I've got ink binning our chip.bin. And then I'm asking it to add 64 kilobytes of blank data, right? I could put, if I put 0 on that, does that change that? I don't know that it does. Let's have a look at it in HXD. No, it doesn't. So now let's have a look at this again. So if we open up data chip.bin, you'll notice that that's the start of our data, and it's tiny, this, right? So it ends with that. You can see the end of a copper list, and then like a long word of nothing, right? I thought there'd be more in there, to be honest, but there's nothing in there. Oh, okay, that makes sense. So copper list. Let's go back up. Actually, yeah, chip copper list, and you'll see here FFV, and then bam, nothing. Oh, this even removes those leading zeros. Sorry, those trailing zeros. So yeah, I know that's a bit bright. HXD doesn't have a I don't need to use ds.b in this instance, I don't think. So basically what happens is the way Viasm will build the executable, it'll realise that you've got trailing zeros after it, and it'll make the hunk size that big, right? Even though the only data you've got is that big, it will say, well, the hunk's that big and all this is just nothing, right? So yeah. Hey Cammy, how you doing? Welcome in. So that works, right? So what we need is there's two things we need, right? So we need to know we need to know how much space we need here, right? So let's go back to our C# shenanigans, right? Hunk ripper, no, not there. And maybe there actually. Actually, we could determine it off of the older, off of here, couldn't we? Right, so let's just go here. We need to know how big this stuff is first, right? So in data chip, right? Oh, sorry, hunks, new hunks. Okay, here we go. So the data size is A30. Right, so let's go and have a look at this. I'm glad this chip hunk is so small. So A30, so that's how much data it thinks we've got, and then that is the relock table afterwards. So actually, so our data file, we know how big that's supposed to be, plus we've got 2 long words at the front that tell us where the BSS section starts and how big the BSS section is, right? So what we need then is let's think this through logically. So A to C there, so that'd be 2 long words. So it will be, if I can think this through, okay, actual sizes needed, right? So typos are free. Actually, okay, so data size plus 8 equals main chunk, right? We also know what the BSS size is supposed to be, and then so what we need to determine is how large the BSS, how large the relock table is, right? It doesn't tell us that from this, does it? Does it? Relock. Okay, no, it's serialized that. So it would make our life a bit easier if we knew how big that was, wouldn't it? Rather than us having to just assume. Oh, fuck it, we can just assume it, right? So, so what we need is a chip buffer, right? Which equals. Anybody else's head hurt? Mine does, and I'm here coding it. So what we need, right? So, I mean, all right. This never ends well, but I'll try it anyway. Right, here we go. So our executable, our binary file has basically a long word here, and a long word here, and then a big old chunk of data here, and then a big old chunk of data here. Right, and then an assumed magic section over here of a certain length, right? So that points to the location here. So that is effectively, actually no, that's wrong, right? Forget about that. That's basically our BSS section. So our section that doesn't, it's just RAM, right? It's just like a memory allocation, right? This then tells us how long that is there, right? Beautiful. And then this is our actual physical data. So what we need to do, inside there we've got a little bit here which is our, we'll call that R, which is our relock table. What we don't know is how big that fucking thing is. So we don't know how big of a memory allocation we need past here. So basically that's it, right? You understand? Great. Right, let's move on. Okay. And what we also need to consider is we need 16 bytes of space because we're going to be doing a ZXO pack on that as well. Right. So makes perfect sense, right? Yeah, easy. Does the hunk size include the relock? Oh, that's a good point. I don't think it does. So we've got a data size there. No, it doesn't. So it's the BSS position. Data size doesn't include that. Okay, so the calculation should be. Let's look at the fast mem section because that's going to have a much bigger. There's going to actually be some shit going on in there. Yeah, so BSS size is 1B3. Right, so let's start with fast. Right, so fast equals new hunks 1 dot BSS size, right? So that's the total size that we need for that area. But what we need to do is we need to work out relock size, which is new hunks 1 dot hunk size, isn't it? Where is that? Hunk size, okay, plus 8. Right, that's right, isn't it? Because the hunk size is 2C. Yeah, that's right, because those aren't included, right? Okay, and then it would be new hunks 1 dot data dot length minus that. Okay. Okay, if the relock is smaller than BSS, then you don't need extra allocation, I think. Yeah, you're absolutely right. BSS size will do it, but then we'll be over allocating how much space we need. Because the BSS could be larger. Okay, so relock size is negative, so that's not worked out well, has it? Oh, hang on. Data size, that's why. Right. Okay, data size, there we go. Right, we shouldn't end up with a negative this time. Oh, you fucking bastard. Okay, let's try it again. Okay, so the data... Okay, then that's the size of the relocation block, right? Okay, that's good. That's correct, I think. So we can test that. We can test that. So it's 2E4, right? So open as a what? All files. Where? Oh, that's why. Fast stop bin. Okay, so go to there. 1, 2, 3, 4. There we go. 1, 2, 3, 4. Okay, yep. So that's the relock size there. So how big is that? 2DC. 2E4. Okay. Okay, that's because we're not supposed to add that on. That's how big it is. 2DC. So that should now say 2DC. Okay, right. So what we're now going to do is plus 16 to that. Beautiful. Because that's our compressing buffer. But that'll do. So that's the size of relock. Right, so fast buff equals new hunk 1 dot BSS size minus relock size. Right, there we go. Okay. So fast relock size. This is so hacky, but fuck it, we'll go for it. Fast relock size there. And then we just need a chip relock size as well. Chip relock size. And then chip buff. There we go. I'm not reading anything at the moment. Let me just get this. Let me get this out, right? Yeah, that's quite a nasty swear word on the stream, but there we go. Okay. Okay, so our fast buffer says we need that many bytes, and that one says we need, oh, quite a bit more bytes. Okay, that's fine. So, right. Who's the Bagon remix by? I think that's by Esau. I think. Bloody good. Var SB equals new string builder. Right, string builder. There we go. Yep, and then we will write into string builder append line chip underscore buff equals. There we go. Chip buff equals chip buff. Yep. And then fast buff equals fast buff, right? And then file dot write all text. Where's the old path dot combine? There we go. Let's do that. There we go. We'll call that zxc0.i, right? There we go. sb dot to string. There we go. Right. Haha. Right. I'm a chip buff, mate. Yeah, mate. I'm English. Of course, I'm a chip buff. Right. Okay. So now we haven't compressed anything yet. So all we want to do is in here is include zxc.i, right? So dcb.b chip underscore buff, comma 0, and then in here fast buff, right? Okay, yeah, that's looking good. That is looking pretty good, actually. I know we've gone slightly above than what we need to, but that's fine. Right, so now, okay, move m.l d0 to a6 minus sp, right? Do some shit. I haven't thought about how we do that actually, but that's a good point. Oh, actually, we could just do this, couldn't we? Jump data underscore fast plus 8, couldn't we? That would work. Okay, so now I need to go and steal my relocation code, and I've written this somewhere else before, and it'll be in it'll be in Seekanoid somewhere, won't it? Disk. Oh no, I've ruined that one, haven't I? That's right. Metal Gear. No, sorry. Amiga Gear. There we go. Disk. There we go. Loader. Yeah, that's the one. And then in here we'll find relock. Okay. So I want that. I want that. Yeah. And then I want that. Okay, yep. And then we want relock. Hang on. Okay, and we'll just copy that. Where's the clear BSS as well? Is that not there? It should be. Hang on. Clear BSS. Yeah, there we go. Relock. Yeah, that's good. And then clear BSS. Oh, I see. I just. Whoop. Okay, let's just steal that from there. There we go. Beautiful. Right. Now. Okay, let's have a look here. Move that. So, okay. Bro, how hard would it be to hack NASA for you? Very hard. I know nothing about security. Ugh. I mean, I do. I mean, I know that most of it is basically social engineering. So, you know, don't answer questions on the phone. It's a stupid thing to do. chip data, and that's chip data. Yep. Okay, and then fast data fast. Yeah, data chip data fast, and then data fast. Yep, and then that. Okay. Build. Does it build? No. Oh no, that's why. Okay. Right. So let me explain what we've done so far. Right. Is I've turned an Amiga executable into 2 binary blobs of data. All this, so see this bit of code here, that, and that. All this does is basically relocate the code to wherever it's been loaded into memory. We're going to add the compressor on after this. But I just want to test if the relocation works first. Right, so I'm going to put in a breakpoint there. Move that over a bit. Okay, data chip, data fast. Relock, relock, clear, clear, clear. Okay. And that's going to jump to data fast +8. Okay, and let's look at the disassembly. Right. Does it work? Does it work? Right, let's minimize that. Right, so we can see the WinUE. Okay, here's the time. Oh, that's disappointing, isn't it? Of course it doesn't fucking work. Why would it work? It looked like it should then. Okay. Data fast +8. Okay. We don't care about data registers. Okay. Yeah, no, that should work. Moves right. Work on the first try would not be very content. Very good content. No, this is true. It would also not make me very content, would it? Let's just out of curiosity, right? Hey Gerbil, how you doing, mate? That's interesting. Theoretically, that should work, right? Maybe what we can do is we can debug the fucker. Right. Oh, that's even more interesting. Why is that not working? Because that's not there. Okay. We're not calling the packer at all. We haven't packed anything yet. All we've got is the 2 binary blobs of data. And we're relocating those blobs of data into the areas of memory they've been loaded. So this is like the post-process after unpacking, basically. Okay, into A3. Okay. This has got a lot more relocking to do. Oh, okay, that. Hang on. Oh, yeah. No. That's absolutely right. Jesus Christ, yeah, that is schoolboy, isn't it? Okay. Yeah, that might help. Yeah. Well spotted. Yeah, that is fuck off, new screen. Right. How many times did I do that? Yeah. It's a classic, isn't it? What's the other classic one? Scratching your head wondering why the bloody Copolis isn't working until you suddenly realise it's in bloody slow RAM. Yeah. We've all been there. Right, now. We're going to pause it. Oh, you... Oh, hang on. Has it smashed up all the RAM? No, because we've allocated the correct amount for each block, right? Exactly. It's beautiful. It's absolutely beautiful. Right, so in terms of the binary chunks, we're good. So now we need to pack those chunks and then include those, shift them up to the top of those chunks, unpack them downwards, then run that process, and then run the demo. Right. Time for some lossy compression. No. This isn't the idea of this. I am going to do a BRB, and we've already done the other one, so which one do you want? I mean, I know which one you're going to pick as your second, right? It's going to be the X-Copy one, isn't it? Mate, I can read you lot like a freaking book. Right. I'm going to do a BRB, make some tea, get some more beer, and I'll be back. We're going to ZXO compress these. You're off to bed, Minimo, mate. Lovely to see you, mate. Take care. Catch you on the Discords, and see you in a bit. All right, I'll be back in a bit. Don't worry. We're not going anywhere. You have some X-Copy. There you go. Oh yeah, and I paused that, didn't I? Where is it? There. There we go. Right, so where were we? Your sub likes this track. Thank you very much, Neversoft. Can you get the name of that tune? That tune is called Trilateral. It is from this game here. Let's just do the let's do some PR. There we go. This game here, Seekonoid, on Amiga. You can buy it in a box. Well, not at the moment. It's slightly out of stock at the minute. It's a tune called Trilateral. It is the main game music from this. It is an Amiga game, a big box Amiga game you can buy kind of, well, soon. It's oh god, no, I can't open it. Anyway, you can buy it, Thalamus Digital somewhere. So yeah, it's a game I made. Hey, that is working. Okay, yeah, good. Yeah. If you look online, I think you might be able to find the Pro Tracker modules for it now, because I released those things out. So right, okay. So I need to be able to pack the files first. Then, right. So, oh, that's a really good point, actually. Oh fuck. Okay. So we need more space. Okay, right. Okay, let's pack the files first, right? There it is. Right. Okay. So that will tell us what that is. But actually, we need to be fast buff and chip buff need to be slightly bigger than that. They need to be everything. It needs to be everything. Okay, right. Let's pack the files first. So if we're going to steal some more code, because that's what we do around here. We've already written the code. Why write it twice, right? So in the TTE disk builder, I have a thing in here that will run ZXO pack. Or ZX pack, I think I've called it. There we go. That's a file name. I don't want a file name. I want the binary version. There we go. So this little function here, I can pass it a byte array, and it'll return me a byte array of packed data, right? Which is beautiful, right? So var chip packed equals data ZX pack chip data, right? Ooh, whoops. Chip data, right? And then var fast packed equals ZX pack data fast. Okay, yeah, I can't data fast. There we go. Beautiful. Right, so now we should have, if we set a breakpoint around there, oh, I see that spat out there. Oh, it's packing. You can see it packing, actually. Okay, right, good. Right, so we've got a chunk of data that's packed, that's chip. A chunk of data that's, oh, hang on. Data chip, that would help, wouldn't it? That's wrong. Yes, Hoover, yes, I know. Pack, lovely. Okay, so we've got chip packed. There we go. DF, yeah, that seems about the right size, and that also seems about the right size. Right. So now our buffer is actually, we need to work out what the total space is required minus the packed data that we've got. So that's what we need to work out, right? So the fast size is actually fast buff okay, minus the relock size, okay, which includes that 16 bytes of space, I think. Okay. Plus, hang on. Oh yeah, plus, okay, so we'll call this fast total, right? Fast total equals that plus, so that's the relock size, yeah, okay. Is there an easier way of calculating this? Yes, there is. So, actually all we need to know is the original data size plus the BSS plus our compression hang on, so let me work this out again. So data size, BSS size, plus 8 plus 16 will give us our total memory that required, and then we subtract. Okay, yeah, there we go. Okay, right. Let's redo these calculations. I've got it. Right. So, fast total. Fast total equals data size plus BSS size plus 16. Right, that's our grand total. And then what do we call this? Fast buff. Fast buff then equals new hunks 1 dot fast packed minus fast packed, sorry, it's dot length minus fast, no, other way around, Ian. Fast total minus the compressed size. There we go. Okay. And then we want chip total equals data size, BSS size plus 16. Might need to increase that a bit actually. And then chip buff would equal chip total minus chip packed dot length. Right. Okay, cool. And then what we want to do is around here, right, chip dot pack and then dot pack, and then we'll have chip packed, fast packed, right, and let's just run that. Okay, that's looking interesting. I mean, he didn't error, which is great. So in here, so if we do chip pack, is that what we called it? Pack, build that. Okay, the sizes look slightly larger. 332,304, 32228. Okay, so I've increased. I may have given myself a bit of an extra buffer, but that's fine. Okay, chip data underscore chip underscore end. Okay. Okay, data fast. Data underscore fast underscore end. Right, okay. Right, this all makes sense in a minute. That's not how big the executable is going to end up being. But now we need an uncompressor, right? Was it hit by fist RAM? I mean, that's the thing today, isn't it? Fist RAM. That's what slow RAM is. It's just fisting you. Horrible RAM. Right. There is a faster version, but let's just go with code/TTE loader. Let's just use the original for now. Okay, new file. Paste that into there. Save as zxo.asm. Right. Okay. Oh dear. Oh no. No. There, that's better. Okay, main.asm in here. Include zx0.asm. Right. And that's still going to build because it's going to be happy. Right. So. All of that remains the same, right? So the data is going to end up in the same place. So what we need to do is we need to, for chip and fast, we need to move the data to the top of the section block, right? Then we unpack back to the start of the block. That's what we need to do. And we could do this for let's have a think now. We could do this, we want to do this in a way that doesn't use loads of code, right? So we probably want to do a function for this to move, unpack, right? So put an RTS in, right? So okay, so what we'll do is we'll do chip underscore size equals data chip end minus data chip, right? So it's chip size, right? Chip size fat, that's what you want. And then fast size, we'll do the same here. Fast size equals data fast end. Okay, so we now know how big each of those chunks are. Okay. Oh, this should be quite easy actually. So what we want to do is LEA data underscore chip, comma, we'll put it into A0. Move.longword chip underscore size into D0, and we'll BSR move unpack, right? Move unpack. There we go. And then we'll just do the same for fast, right? Data fast, and then fast size, right? So A0 contains how big the data is. Right, so what we want to do is chip end and then fast end. Okay, cool. Right, so that's the end of the destination. There we go. Right, okay, so we'll need another address pointer there. Chip underscore end A1 and then fast end there. And that's the fast size. Okay, right. Cool. Let me just grab that. And down here. Oof. No. No. There we go. There we go. Lovely. Right. So. So add .longword D0 to A0. Okay. Dot copy. Move dot bit. Byte, sorry. Minus A0 into minus A1. Right? Oh, that's the other thing we need. Is we need where it's going to go. Data chip. Okay. Actually, so what we want to do is move.longword A0 into A2, right? So that's going to copy it downwards. Subq.L 1 from D0. BNE.copy, right? Right, and then when we're here, A0 will equal start of packed data, and A2 will equal destination, right? So what we want to do in that instance is move.longword A2 into A1. I could make this a bit more optimized. BSR ZX, so decompress. No way. Okay, right. Let's see if that builds, right? Jab, time for bed. I'll finish offline. No worries, mate. Thanks for tuning in. I'm completely ignoring chat. You'll realise what happens around now when I start getting into the zone and we start building something. Right, let's see what happens. Okay. A0's got a data chip, and that's the end. Ah, no. I fucked this up. Okay. Okay, so what we want to do, actually, is we want to move A1 into A0, because that is the start of the pack data, and then move A2 into A1, which is our destination. Okay, right. Right. Okay. Right. Oh boy. Okay. Let's hide that. Move that down. I haven't got any watches at the moment anyway. Okay, there we go. Right, let's have a look then. A0 into A2. That's our destination. A1's the end. Okay, add D0, which is okay. Move that to there. Okay, yeah. Copy. Right, okay. Move A1, which is now... In fact, if we do a quick watch, I think they should match, right? 20 bytes, 1. It's fine. And then we'll put that into A1 as well. There we go. Oh, there we go. That's what we want. That is exactly what we want. Okay. Move A1 into A0 and A2 into... Okay, and then ZXO decompress. Okay. Yes! Just put beer all over myself. Like an idiot. Right, okay. So, now I want to test it against something, right? I think we're happy that the Hunk compressor works, right? Not until it has a go with the tube. The only thing you're gonna get is a. I can do you one. It'll be a .NET WinForms application, and it'll have a Pro Tracker module, but it'll only run in 32-bit mode. I'm not touching DPaint, mate. No way. Right, but I am interested in one, right? Which is... Nova 2022. Okay, so let's have a look here. C:/code/ Nova 2020 to Nova 22. Right. UAE DH0. Demo packed. Right. So demo packed. So this is Tech Nova. Right. Fuck it, we'll take it. Challenge accepted. Alright, I might do that then. Alright. The ultimate lame packer. Because obviously I have to include VASM to be able to build the executable as well, right? But yeah, anyway. Right. This. So this annoyed me, right? So this, I packed this with Cranker. Cranker doesn't clear BSS sections. My packer does, because it's using my relocator, which also clears the BSS sections, right? So that's I wonder if find tech, no, find internet gobshite bifat, no. Okay, so alright, at least I don't put any crap in the executable. I'll give him that. My question is, well, the latest Cranker does, maybe, but when I used it, it did not. So, it's a great tune as well. So, I'm curious if we can do a... let's do a competition, right? So let's have a look then. Admittedly, the memory copy's a bit shit, but we might be able to improve that. I mean, we could definitely improve that, right? If we can make it word aligned. Okay, so we can get rid of that now. We don't need that anymore. Okay. Slash demo. Right. Oh yeah, I'm sitting here waiting for it, and it's done already. Okay. Okay, so does it work? It does. It does. Right. Okay. Right. Cool. Right. So the other thing we need to do then is build a release version of the executable, so it throws out all of that junk that we don't need. Right. So we can cheese that by just doing, I think, build release main, and I think if we just do minus s, right, and then if we do, let's check the size of it first, right? C:/code/ Zexy Asm UAE DH0. I know the 127. Okay. Build main. Okay, build release main. Okay. 125. Okay. Actually, it's 124. Okay. One, two, four. Okay, so we're definitely below Cranker already, right? So, well, let's just double check that we don't have any fluff in there, right? Yeah, that's good. That's good. That's good. Okay, debug symbols are gone. That's good. That's good. Right. Okay, right. So that's RXE, right? So let's make a disk image of that. dir, so exe to ADF. Intro is main, and we'll call this Zexy0.adf. Right. So, whilst that is right into disk on demo disk 1, I missed it. What does the mem look after the magic? No idea. I'm sure it's fine. But basically, the executable's put into 2 big blocks, right? So it's fine. Blitter object. Oh yeah. So basically, anything in chip RAM is 1 block. Anything in public RAM is another block. BSS sections are at the end of both of those blocks. So basically what happens is if your executable was to load that way, yeah, that's basically the kind of memory it would use. The only additional memory you're going to have left over, really, is that code there, that code, and also a ZXO compressor, which is not a lot. I think it's actually probably, we'll probably work it out, but that first section in there is how big will be left over. Otherwise, the only extra RAM you're going to use versus loading uncompressed is about 16 bytes per chip RAM per fast RAM. So 32 bytes plus the decompressor. And the decompressor's small anyway, so yeah. So yeah, it's nothing really. I mean, I don't verify that it's going to be any good. We're just putting it through its paces now. So, right, let's write that to disk then. Okay, so that's a Zexy. Let's write that to. Oh yeah, that doesn't work, does it? Because we're using pre-release disk thingy. Floppy drive. Copy file to disk. Okay. Okay, that's copy into disk. That's demo disk 1. So we're gonna have a race. Let me just tidy this up a little. C:/code/. So first of all, we have to remember that our executable is 124 kilobytes. Cranker has generated an executable that is 135. Is that 135 or is it 134? 134. So 10 kilobytes larger. Right. So let's make a disk of that as well, and we're going to give them a race, right? There's actually an ADF there, but let's just make a new ADF so we know exactly what we're dealing with, right? Minus I, demo-packed, yeah, minus A, cranker.adf. I mean, if I did the speed loader, we'd absolutely floor it, but you know. This is true. Cracker. I mean, cracker's fine. That's fine. Cracker.adf. Copy file to disk. I'm just curious. I mean, he's probably going to win in terms of loading speed. Cracker.adf. There we go. Right. I was going to suggest release the Kraken. Yeah, we are running desperately out of time, but here we go. Right, it's fine. I'm happy with this though. This is what I wanted. All right, we also have to remember we've beaten Cranker by 10 kilobytes. So you know, we could also probably do this as if you can work out, you'd end up losing more RAM. But we could do it with deflate, and you'd still get like shrinkular size executables, but without the decompression time. But you're going to lose a lot of RAM with the stack. You're going to lose a lot of RAM with the safety zone. But you know, it's an experiment, isn't it? You know, we've got something to play with now, which is what I wanted to get to today. LZMA or bust. Well, that's what I'm saying. Deflate would do it fine, but it's calculating the safety zone with Zopfli, which is the complicated bit. If I can get that nailed, I mean, it does do in-place decompression, but you just need a massive fucking buffer for it. Right. Okay. Okay. Right, so okay, fuck it. We'll leave that. Leave that. I want that one. Okay. Timer. Stopwatch. Okay. Oh god, wish me luck here. Add. Last time I did this, it crashed live on stream. Okay. Capture games. Can I capture? Yeah, screen capture. No, cancel. We got window capture. Where the fuck? How do I even write this thing? Here we go. Window capture. Watch. Okay. Window. What? It doesn't even show up. Okay. Here we go.
Now I see clearly. My whole life is pointed in one direction. I see that now.
No. Here we go. Okay. Bingo. Right. Balkan. Right. Let's pause that. Right. So we're gonna go with Cranker first, right? I don't know when we're gonna do it to though. But let's start. I'll start as soon as the disc goes in. Oh shit! Hang on. That's alright. It's alright. Hang on. Right, just in case anyone thinks I'm cheesing the results. Right, we'll do that again. In. Can't have you thinking I'm fucking with this. So I guess when the screen goes black, then it's when we're going to hit stop. Oh, unless that's... Okay, well the demo doesn't even work. After 21 seconds. Is this a Windows Speed Boost speed? It's a Windows Boot speed test. Oh, there we go. Oh no, the demo doesn't work. Okay, the demo doesn't work. Right. So 21 seconds to black and the demo didn't work. Right. Cool crowd strike. Right. Oh no! Cheesed it. I did cheese it. Cheesed it. Right. Let's try it again. No cheating. No, I don't want no cheating. It's 1 second slower. And the demo works. And it's 10k smaller. we go. 1 extra second, and it really whips the crankler's ass. Oh, well, that was fun. Oh, brilliant. Right. Woo! Excellent. I'm happy with that. Clap for the cruncher, clap for the demo. Thank you very much, Zeron. Thank you very much. I mean, there's no guarantee the file could get distributed in DiskFlashback results with more seeking. I mean, yeah, if you produce your own ADF, then, you know. But I produced both of those ADFs in the same way with the exe to ADF, which produces the file sequentially on the disk. So, you know, they both had the same chance. So, seek annoyed. Brilliant. Okay, that is better already. Yeah. Right. Give me a demo. Give me a suggestion for a demo. Come on then. What do you want to see? Anything now, because we've got a fantastic new version of DiskFlashback, which works with weird DMS files now, so we can really put it through its paces. Come on, give me a demo suggestion while I pour a beer. Something old. Well, you have to tell me what old something you want. Mind Riot, Hooverphonic. I mean, that's a good shout, actually. Yeah, I'm not debugging Seekanoid now. Call of the Wild. Is that an OCS demo? Oh, mate, mate. I need a flake with that, don't I? Call of the Wild. Let's look it up. At the Dailius, Emmett. How you doing? Of the Wild. Oh, mate, that's Boozaholics. No, that's an AGA demo. I mean, we could do that, but 3D demo. Oh, that's okay. 3D demo. And Hooverphonic. We'll see. We'll see about. I'll get Mind Riot writing. Oh, we need 2 discs for this. Okay. Yeah, and then save. Oh, for fuck's sake. There we go. Save link as. Jesus Christ. So complicated now, isn't it? Slide. Yeah, we did run that one recently, I think. Now let me just let me get this unpacked. Downloads. No. Desktop DM. Oh, for goodness sake. Okay, DMS, there we go. Okay, and then let's go there. And then just go back again, and then go there. And then save link as, yep. 2, there we go. Okay, beautiful. Okay. Right, so. Disk 1. DiskFlashback. Floppy drive, copy file to disk. Okay, here we go. Oh, you can't see anything, can you? Hang on. There you go. You see what I'm doing now. Desktop, DM, disk 1. Yep. My little timer Windows outside my prawn. There, mate. My prawn's not on my desktop. It's 2024, mate. No one has their prawn on their desktop anymore. No one stores prawn anymore. It's not like 2004 when my mate had a meticulously arranged RAID array of prawn files. A prawn curry, yeah. Ooh. So, you know, we're going to really go for this as well. I'm going to... we're going to run the demo on disc 1 and write disc 2 whilst we're watching the demo on disc 1. And hope to God you read... Booney, come on. Just in time load it. Yeah, here we go. Right, I'm gonna give us a fighting chance though. We're gonna start writing that disk. Copy file to disk. Okay, right. 3D demo by Anarchy. This is a banger actually, to be honest. I love this demo. I went mental for this. Here you go. There you go. Alright, let's see what's on disc 2. Nothing. Okay, well you can't boot from disc 2. Maybe they've got a special boot block on there or something, but there we go. There we go. 3D demo. I mean, that rave tune is just so good. So yeah, by request, this is what we're watching next. Ooh. That font was weird though, wasn't it? It's very dark. There you go. Mind Right by Andromeda. I think that was Pyru. I think you requested that. But yeah, really nice code for 1993. Really lovely. Now, come on. He better be on. Oh, he is! Yes! Right, that wraps us up for this evening. Thanks everyone for tuning in. Hooverphonic, Pyru, Neversoft, Commander Keen, Xeron, JC1980, everyone else. Thanks for all the sub drops. You lot are amazing. Just bonkers. Commander Keen, Clayton, mate. Lovely to see you there, mate. I don't think I've said hello yet, but yeah. Booney as well, Neversoft, Darkstar. But yeah, we are going to raid Charlie because he's back off holiday. So, yeah, the lizard. Hang on. I tell you what. Let's roll out with
US Gold present from Sega.
There you go. That's how we roll off. Thanks, Neversoft, Xeron, Blitter Object, everyone who's tuned in this evening. You lot are amazing. Thank you very much. And we've got an executable packer now. I mean, it's an absolute mess, but it works, right? And it takes 1 second to load slower than Cranker. But it does make a smaller executable. So, yeah, there you go. And it uses not very much RAM, so this is great. Anyway, I will catch you all Monday next week. We'll be doing some DJing, and then we'll be back onto something. I'll probably take apart the 500 next week on Wednesday, and we'll put the drive in. Let's do a hardware stream. Debro Germany, thank you very much, mate. Neversoft, Blitter Object, Xeron, everyone else, much love. I will see you all very, very soon.